Hello guys, so this is question number 19 of engineering thermodynamics that appeared in civil services mains examination in the year 2003 for 20 marks. So let us read the question. Calculate the decrease in available energy when 25 kg of water at 97 degrees Celsius is mixed with 35 kg of water at 47 degrees Celsius. The pressure being constant and temperature of surrounding is 25 degrees Celsius. Specific heat of water is 4.2 kilojoule per kilogram Kelvin. So in this we have to calculate the decrease in the available energy. And we know that the decrease in available energy is given by Gauss-Tudela theorem, that is T naught multiplied by S generation, that is the total entropy that is generated. And now total entropy that is generated will be the entropy of the system plus the surrounding. Now the total entropy change is given by the formula delta S is equals to mass multiplied by Cp ln T2 by T1 minus R ln P2 by P1. Here we know that the pressure is being constant, so this second term is always equals to 0. So the formula that comes out to be delta S is equals to the mass multiplied by Cp multiplied by ln T2 by T1. Now we assume the final temperature of water as T Kelvin, that is after mixing the water at 97 degrees Celsius and water at 47 degrees Celsius, we should get a temperature T. So first we have to calculate what should be the value of the temperature T. Now we have to apply the principles of heat exchange, that is mass of water A multiplied by Cp multiplied by 370 minus T. Now 370 is Kelvin, 370 Kelvin minus T, so its temperature will decrease. So is equals to mb into Cp multiplied by T minus 320 because its temperature will increase. Now we plug in the values here, we get 25 multiplied by 370 minus T should be equal to 35 multiplied by T minus 320. Now from this we can get the value of T as, so T is equals to 340.83 Kelvin. Hence, the change in entropy for 25 kilogram water should be delta S is equals to the mass of water, that is 25 kilogram, multiplied by Cp of water, that is 4.2 kilojoule per kilogram Kelvin, multiplied by ln T2 by T1. So its final temperature changes to 340.83. So 340.83 divided by initial temperature, that is 370 Kelvin. Now we plug in the values, we get the value as minus 8.62 kilojoule per Kelvin. So this is the entropy change of water A. Similarly, we can calculate the entropy change for 35 kilogram. So delta S of water B is equals to 35 multiplied by 4.2 multiplied by ln 340.83 divided by 320. We can get the value as 9.27 kilojoule per Kelvin. So we have calculated the value of delta SA and delta SB. Now we have to calculate the net entropy change during the process. So it should be equal to the summation of delta SA and delta SB. So delta S total should be equal to 9.27 minus 8.62. Now this comes out to be 0.6502. 0.6502 kilojoule per Kelvin. Now from Gauss-Tudor's theorem we get the value of irreversibility, that is equals to T naught into delta S is equals to decrease in the available energy. So if we plug in the values here, 298 multiplied by 0.6502, this becomes 193.77. ठीक है. Now we have calculated the value of decrease in decrease in the available energy of the system. Hence, the question is solved. Thanks for watching. See you next time.